Hello viewers, today we will discuss about Central Processing Unit. The Central Processing Unit performs data processing operations. Central Processing Unit understands only machine language or binary language. Programmers or users write their instructions in the assembly language or in high level languages. Instructions written in user programs are translated in machine language by using translator. Translator follows the instruction set for the desired central processing unit. Intermediate results while data processing operations are stored in the registers. Okay, first of all, we will discuss about machine language. Software refers to the program that is written for the computer. When a processor in a computer system is executing a program, the program is in a machine language. However, programmers never write their programs directly into this form. It is translated to a machine language at some point before execution, so that it is understood by the central processing unit. Machine language can be directly interpreted by the hardware itself and is easily encoded as a string of binary bits that are sent easily via electrical signals. Programs written for a computer may be in one of the categories. The first one is binary code. It represents the exact representation of instructions in binary form. Second is octal or hexadecimal code, the translation of binary code into equivalent octal or hexadecimal representation. The third one is symbolic code. Symbolic representation is used for the parts of the instruction code. Each symbolic instruction is translated into one binary coded instruction by a program called an assembler. The fourth one is high level programming language. This type of programming language allow the specification of a problem solution in terms closer to those used by the human beings. These languages were designed to make programming far easier, less error prone, and to remove the programmer from having to know the details of the internal structure of a particular computer. The program for translating a high level language program to a binary is called a compiler. Machine language program is a binary program of binary code category. Because of the equivalence relation between symbolic to binary and octal or hexadecimal code, octal or hexadecimal code category and symbolic code category also comes in machine language. Program for adding two numbers in binary code and in hexadecimal code is shown in the table. As we can see from the table that binary instruction code consists of sequence of zeros and ones. The hardware of the computer will execute these instructions and perform the required task. However, for human beings, understandings of the program will be difficult, but the computer hardware understand only this type of instruction code. Hexadecimal representation is convenient to use. However, one must realize that each hexadecimal digit must be converted into binary code when the program is entered into the computer. We can go one step further and replace each hexadecimal program by symbolic programs. Symbolic programs are easier to handle, and it is preferable to write programs with symbols. These symbols can be converted to their binary code equivalent to produce the binary program. In symbolic programs, hexadecimal addresses are replaced by symbolic addresses and hexadecimal operands by decimal operands. As we also know, decimal numbers are more familiar than their hexadecimal equivalents. Table shows assembly language program for adding two numbers. The symbol ORG followed by a number specifies an origin, that is, the memory location of next instruction below it. The next 3 lines have symbolic addresses. Their value is specified by their being present as a label in the first column. Decimal operands are specified following the symbol DEC. The last line has the symbol end, indicating the end of the program. If programs were presented in a language that is much closer to human language, solving a problem results in fewer mistakes. High level programming languages allow the specification of a problem solution in terms closer to those used by the human beings. One of the first of these languages was Fortran, where we can see a Fortran program from the table written for adding 2 numbers, which is obviously much more readable, quicker to write and less error prone than the assembly code. The computer does not understand these high level languages directly, and hence they have to be processed by passing them through a program called a compiler, which translates these languages into internal machine language before these languages can be executed. Next topic which we are going to discuss is assembly language. A program in any program language is defined by a set of rules. Users have to follow all the language format rules so that it can be translated and understood by the computer. Every computer follows its own assembly language. These assembly language programs are provided by the computer manufacturer. The basic unit of an assembly language program is a line of code. The assembly language is defined by a set of rules that specify the symbols that can be used and how they may be combined to form a line of code. Now, we are going to discuss the rules of an assembly language for writing symbolic programs for the basic computer. Each line of an assembly language program is arranged in 3 columns called fields, which are explained as: first one is the label field. It may be empty or specify a symbolic address. A symbolic address consists at the most the 3 alphanumeric characters. The first character must be a letter, the next 2 may be a letter or a numeral. Symbolic address is terminated by a comma so that it will be recognized as a label by the assembler. Second is the instruction field. This field specifies a machine instruction or a pseudo instruction. Pseudo instruction is not a machine instruction, but rather an instruction to the assembler giving information about the translation. The instruction field may contain any one of the 3 types of instructions. The first one is a memory reference instruction, the second one is a register reference instruction, and the third one is a pseudo instruction with or without an operand. A memory reference instruction occupies 2 or 3 symbols separated by spaces. For example, add OPRI, the first must be a 3-letter symbol defining memory reference instruction operational code, the second is a symbolic address, and the third is the optional I indicating indirect address. For example, CLA, INC, etc. A non-memory reference instruction is an instruction that does not have any address part. It is recognized in the instruction field by one of the 3-letter symbols for the register reference instruction and input-output instruction. A symbolic address in the instruction field specifies the memory location of the operand. This location must be defined somewhere in the program by appearing again as a label in the first column. For example, LDA X1, X1 hex 40. As we have already discussed, pseudo instruction is not a machine instruction, but rather an instruction to the assembler giving information about translation. Then is the comment field. Third field in an assembly language program is reserved for comments. It may be empty or it may include a comment. Comments are useful for explaining the program and are helpful in understanding step-by-step procedure taken by the program. Comments are inserted for explanation purposes only and are neglected during the binary translation process. Now, we are going to discuss the need of an assembler. An assembler is a program that accepts its symbolic language and produces its binary machine language equivalent. The input to an assembler is a symbolic program also known as source program. The output of an assembler is a binary program also known as object program. Prior to assembly, the program must be stored in the memory. A loader program is used to input the characters of the symbolic program into the memory. A line of code is stored in consecutive memory locations. The assembler scans the symbolic programs 2 times. The first scan is called the first pass and the second scan is called the second pass. First pass of an assembler generates an address symbol table that connects all user defined address symbols with their binary equivalent value. Second pass of an assembler does binary translation with the help of an address table generated during the first pass. The assembler uses 4 tables. Any symbol encountered must be available as an entry in one of the tables. The first table is pseudo instruction table. The second table is memory reference instruction table. Memory reference instruction table consists of 7 symbols of memory reference instructions and their 3-bit operation codes. Now, the third table is non-memory reference instruction table. This table consists of symbols for the 18 register reference and input output instructions and their 16-bit binary codes. Then comes the fourth table. Address symbol table that is generated during first pass is the fourth table. The assembler searches the 4 tables to determine the binary value of the symbol that is currently processed. One important task of the assembler is to check for possible errors in the symbolic program and print an error message for each to the programmer. Now, in the next topic we are going to discuss is instruction codes. The organization of a digital computer system is defined by the sequence of micro operations that it performs on data stored in its internal registers. The user of a computer can control the process by means of a program. A program is a set of instructions that specify the operations operands and the sequence by which processing has to occur. A computer instruction is a binary code that specifies a sequence of micro operations for the computer. Instruction codes together with the data are stored in the memory. An instruction code is a group of bits that instruct the computer to perform a specific operation. It is further divided into parts. Each part is having its own particular meaning. The operation code of an instruction is a group of bits that define such operations as add, subtract, multiply, shift and complement. We must understand the relationship between a computer operation and a micro operation. An operation is a part of an instruction stored in the computer memory. It is a binary code that tells the computer to perform a specific operation. The control unit receives the instruction from the memory and interprets the operation code bits. It then issues a sequence of control signals to initiate micro operations in internal computer registers. An instruction code must tell the registers or the memory words where the operands are to be found, as well as the register or memory word where the result is to be stored. Memory words can be specified in instruction codes by their address. What is stored program organization? The simplest way to manage a computer is to have one processor register and instruction code format with 2 parts. The first part of instruction code format specifies the operation to be performed and the second part tells the memory address where to find an operand in the memory. This operand is read from memory and used as the data to be operated on together with the data stored in the processor register. Instructions are stored in one section of memory and data in the other. Computers that have a single processor accumulator register, the operation is performed with the memory operand and the content of accumulator register. If an operation does not need an operand from memory, the rest of the bits in the instruction can be used for other purposes. Then, what is a system? A system is a collection of components that are organized for a common purpose. A computer system consists of hardware components that have been carefully chosen so that they work well together, and software components that run in the computer. So, next topic which we will be discussing is register organization. The part of the computer that performs the bulk of data processing operations is called the central processing unit. The central processing unit is made up of three major parts. The first one is register set. It is a set which stores intermediate data used during the execution of the instructions. The second part is arithmetic logical unit. Arithmetic logic unit performs the required micro operations for executing the instructions, and the third part is control unit. Control unit supervises the transfer of information among the registers and instructs the arithmetic logic unit as to which operation to perform. When a large number of registers are included in the central processing unit, it is most efficient to connect them through a common bus. The registers communicate with each other not only for direct data transfers, but also while performing various micro operations. A bus organization for central processing unit registers is shown in the figure. Here in this figure, the output of each register is connected to two multiplexers to form the two buses A and B. The selection lines in each multiplexer select one register or the input data for the particular bus. A and B buses form the inputs to an arithmetic logic unit. The operations selected in the arithmetic logic unit determines the arithmetic or logic micro operation that is to be performed. The result of the micro operation is available for the output data and also goes into the inputs of all the registers. The register that receives the information from the output bus is selected by a decoder. Control signals are represented in a control word by using 14 binary selection inputs in the unit. From the figure, we can see a control word. It consists of 4 fields. 3 fields contain 3 bits each and 1 field has 5 bits. First field CELA selects a source register for the A input of the arithmetic logic unit. Second field cell B, select B, selects a register for the B input of the arithmetic logic unit. Third field select D selects a destination register using the decoder and its 7 load outputs. The last field OPR selects one of the operations in the arithmetic logic unit. The 14-bit control word, when applied to the selection inputs, specify a particular micro operation. The ALU provides arithmetic and logic operations. In addition, the CPU must provide shift operations. The shifter may be placed in the input of the ALU to provide a pre-shift capability or at the output of the ALU to provide post-shift capability. From the table, we can see that OPR field has 5 bits and each operation is designated with a symbolic name. The controlled word for a given micro operation can be obtained from the selection variable. For example, we want to perform subtract micro operation on the contents of the register R2 and register R3, storing the result in a register R1. Subtract micro operation in the figure specifies R2 from the A input of the arithmetic logic unit, R3 for the B input of arithmetic logic unit, R1 for the destination register and an arithmetic logic unit operation to subtract a minus b. Some of the micro operation examples for the central processing unit are listed in the table. So, with this we complete our lecture. Today we have discussed central processing unit. Central processing unit understands only machine language or binary language. Instructions written in user programs are translated in machine language by using translator. Translator follows the instruction set for the desired central processing unit. Intermediate results while data processing operations are stored in the registers, and so on. So, in the next lecture we will discuss about arithmetic and logical micro operations. Apart from it, we will be discussing input output programming, micro programmed control and stack organization, and other topics. I hope you all have benefited by this lecture. Thank you. Have a nice day.